Hi, just a quick video on this HPTS system, just going through how this is going to operate. So the first screen that you're going to see after download is going to be this screen. This is the directory login screen. It's where you're going to log into the system and where you're going to find um, the different screens, the buttons to get to the different screens. So here it's split up into 6 sections. Main, which just contains the P&ID screen. And that's going to be where 99% of this is going to be the screen that you're going to be on. The next one is electrical troubleshooting, which is the analog inputs and outputs, discrete inputs and outputs. So this is mainly for setting up the sensors, and if there's something happening with one of the sensors or uh, some signal that's not coming through, we'd be having a look in these screens to check it out. Trends and logs, this refers to live trending, and so this is just a graphical representation of the components that's in the system, where you can actually see it on graph form. So it just makes it a little bit easier to look back in time and see different pressures and what have you from that. Historical data, this is everything that's been logged in the system. So as long as we've got a USB stick in the HMI, all the information that's in the system is going to be logged to that USB. Also, a web server is set up on the HMI, so you'll be able to remotely access the HMI to be able to reclaim logs, but the logs will be stored on a USB drive. Alarms, this is for the alarm setup, to set an alarm up for a warning or a shutdown, or to set an alarm up with a value. If we drop under this value, create an alarm. If we go over a value, create an alarm. So we can come to that soon. Then system setup parameters. This is to do with auto mode. This is decay tests, times, vessel height, pressure. How much do we want the pump to fill that? How much do we want the pump to pressurize the vessel, etc., etc. So we'll be going to that soon. System troubleshooting. That's just another way of troubleshooting the system, where we'll be looking at maybe connections from HMI to the PLC, and different sorts of stuff that's internal to the system. Then system functions. This is mainly clean screen here, calibrate screen. So clean screen is if you wanted to give the screen away but not press a button, just press this button and you've got 30 seconds to clean it. And then the other one is calibrate the screen. So if different users might have different tendencies when pushing a button on the screen, you can just calibrate the screen to your finger. So here, if it's in light blue, we could always press these. Anyone can press these without a login. They're just in blue, so you can see that these are enabled. But these other buttons are in light blue. So if I press here, I'm not sure if you can see my cursor, but I am trying to press these buttons and nothing's happening. So what has to happen is that you have to log in first. I've put the username here as MTG, and then the password for MTG is 9999, 4 nines. Press enter, hit OK, and then you can see that you're logged in as a MTG1. So other passwords can be given for this, and you'll be there's a section on it for setting up passwords within the system. But at the moment, we're just going to use MTG1 because this login has access to the whole system. So to log off, you simply press log off. You can see that these buttons are not enabled. So I'm just going to pop in that password again, press OK. Then we can just go to the P&ID first. So this is the P&ID of the system. showing all the valves, the different sensors, the pump. Then the last time I was working on this, we must have been looking at the fluke pressure controller, so that's why that's illuminated there. So what we're looking at is the PNID screen. So once we come in, at this moment in time, we're in stopped and system vented. So the system isn't doing anything, it's stopped. It's in vent mode, which just means that everything's in its default states. The OPVs are in their open state, and then the other valves are in their closed state. The pump is off. The regulator has 0 set point, and we're just in a stopped and vented state. Don't worry about these numbers. This is just me on a simulator. They don't make sense, but I just have some numbers in there. So at the moment, so you can see that there's 2 buttons flashing. So in this stopped and system vented mode, you're able to go to auto mode or manual mode. So here, these are illuminated. Stop and vent, this just puts it into the stop and vent stopped and vent state, and then we've got another button down here called stop keep pressure at VSL-1. The only thing different about this button is that you can stop the system, but it will keep the pressure here in VSL1. And if we were to press that, the only things that change is that OPV7 and OPV1 would close. So all this section here is pressurized, while this section down here is at atmosphere. So I could actually go into manual mode here. Actually, I just press the stop keep pressure at VSL-1 just to confirm that OPV7 closes as long as OPV1. So you can see all in here will be kept at pressure, while down here is at atmosphere. So I'll just go into manual mode. So once I go into manual mode, the previous state is kept until you make a change. So we came in from a stop keep pressure at vessel-1. So we can see here that it's in that state still, but we are in manual mode. And the mode here, this just tells you, again, I'm not sure if you can see my cursor, but where we see mode up near the top, you can see that manual's in green up there. So just to pick a valve, if we picked PV1 to open, we simply just press PV1. So we press PV1, and we can see that PV1 is illuminated and flashing here. So this is double confirmation. So just to make sure that the button press is meant. So then if we press PV1 down there, confirm it, PV1 opens, and then another example, OPV up here. So OPV1 would flash, we can confirm it, and then it opens. Down here, UUT-4, again, green, pump here, pump double confirmation, that's on. OPV7, just say that you didn't mean to press it and you don't want to open it, just simply cancel the selection and press away onto the screen, and you don't have to open it. Okay, so the other thing here is that you have free run on the regulator. You can put a set point in here if you so wish. So if you want to put 5,000 in, you can put 5,000 in. So you're able to input values into the regulator when it's in manual mode. In auto mode, there's no control on this screen. The only control will usually be up here for acknowledgement, confirmation, or a skip. So at the moment, so we just want to go back into, I can go into a stop and keep it pressured VSL1. So we have to be in one of these stops to be able to access auto mode. We can't transition from manual mode to auto mode. So we're just going to press stop, keep pressure at VSL1. So you can see it goes back to the default states besides OPV-1, OPV-7. So I'm going to go into auto mode here. Again, you get a little pop-up screen entering auto mode. Are you sure? you can say yes or cancel. If you press cancel, you just cancel. But hit auto mode, this slides in. Entering auto mode, are you sure? Press yes. So now you can see that we're in auto. When we look up at the mode, we're in auto. The first thing that comes up is choose component from drop-down list on the left. Press confirm when done. So yeah, the last time I did this, I picked M control 01-64. But anyways, we can just drop this down. All of these can be picked. These are the different kits and devices that you want to test for the leak checks and for the pressure checks and everything. So we're just going to pick the first one here, MGAG-0585. So you can see that this guy here disappeared, and now it's just component under test MGAG-0585-kit. So choose component from drop-down list. We've done that, so we can press confirm now. So we've pressed confirm. So the next step is going to tell you to cap FPCCP1 and FPCCP2, because the last one that we had here was the fluke pressure controller, so we have to cap that. So cap FPCCP1 or confirm that you've capped it already. Press confirm when done, so we can pretend that's done. So I confirm that. So press act to close all valves. Press confirm to pressurize vessel -1 and confirm multiplier for the pump. So again, I'm just going to put 1 in here for the moment and just explain what's happening. So for this MGAG, so the reason FSL HSP came up as 9000 PSIA is that the parameter for the MGAG 0585 I had put in as the vessel high set point, that we want the pump to get that vessel up to 9000 PSIA. So I had put in 9000 here. And so the question was press confirm to pressurize vessel -1 and confirm multiplier for pump. So the multiplier, so we're looking here, so the vessel high set point is 9000. The multiplier simply means when do we want the pump to turn on again after it does its first cycle. So we can presume that we're low because we're just going to be opening up PV1 to the house supply, and then the pump is going to pump that up to whatever our VSL HSP is. So it'll automatically turn on once it's below that. It'll go up to 9000. But then if you just left it at 9000 and you wanted the pump to turn on anytime it's under 9000, there could be a time where you're just like teetering on the edge and it's going on and off, and you know, after a while the pump gets wrecked if it's been just overdriven like that. So this multiplier here just means that, okay, when you're under 9000, go to 9000 first time, but then don't start to pump again until whatever you put this multiplier as. So if I put in 0.9567, just say, this would calculate, so 9000, multiply that by 0.95670. So the answer there would be 8610.30 PSIA. So it's telling you it'll go to 9000, but then once it hits 9000, pump turns off. It will not turn on again until it reaches 8610, and then it'll boost up again to 9000. So that's the way you'd use that multiplier. Press confirm to pressurize vessel 1. So we're going to confirm this. So monitoring PT2 equals the vessel HSP. So we can see that PV1 is opened, and we can pretend there's 80 PSI there. And then the pump turns on because we're way under the vessel high set point of 9000. So I've put a watchdog timer of 11 minutes 35 seconds here, but this is changeable. So all these times are going to change once you see the system running. This is just for this example. So we go into parameters. We see here that we've got a VCPT, vessel check pressure time in minutes. So this is 12 minutes. So this is simply this timer, 11 minutes 7 seconds. that's just that timer counting down, and that's going to tell us if there's a problem with the pump or not, or there's a, the vessel is leaking. If you give it a certain time for that pump, you'll know how long the pump usually takes to fill the vessel. So then you can moderate, or you can just change this to something that's closer, and you can trigger alarms from here. So if it doesn't hit the pressure at an expected time, just trigger an alarm and it'll say the vessel has not reached the pressure in the appropriate time, and you can set that for a warning or a shutdown. So that's that. So 10 minutes left on that. So that would be the timer, but the pump is on. So I'm just going to manipulate the pressure here, just to drive it over the 8,000. Okay, so we've gone up to 8,000. Well, the target's 9,000, so the pump is still running. Okay, that's good. So we're well over. So now the pump's turned off because we've got to 9,322. So the comment is PT2 has reached the vessel high set point. Press ACT to pressurize the test component. And also this clock will stop once it's hit the thing. So you'll be able to maybe take a few notes on how long the pump is taken to get this vessel -1 pressurized. So you can keep a note of that, and then you can set the alarm accordingly. So PT2 reached the high set point. Press ACT to pressurize the test component. So we can see here that this is opened. This is at pressure. This isn't come into play yet. We've all this closed. So we're going to press ACT. So now, once we pressed ACT, we're ramping the pressure to the TCI. So we see that this is a 10-minute step. So we go down here. We see that these have a set point of 1600. Again, I haven't put any values in here yet. And then this is pressurizing all the way to the test component. These two valves are opened. Valves behind here, the OPVs, they're all closed at the moment. So the reason we're going to 1600 is because we're going at a 20% pressure target. So we're just bringing this regulator to 20%, and we're going to let 20% get through. So 1600 is 20% of the 8,000 here. We can also see that it's called pressure build because we're building the pressure into it. And again, we've just got a little timer here, the 9 minutes, 4 seconds. The reason that's saying that is because here on this next screen, pressure build time monitor for 20 to 100% for all components. I just set it to 10 minutes there. Again, that'll be changed once we see how long everything takes to work. You'd probably be talking seconds, not minutes, but just for now, I'm using it as an example. So I'm just going to, so our target is 1600. I'm just going to bring PT4 over 1600. Okay. So PT4 is 1600. So then, just doing a pressure decay test of 1 minute, you can see that the decay target is that it can't drop under 15.96, which is just 4 psi off that. The reason for that is we've set up the pressure decay variance, the PDV, at 0.002. So we're going to multiply the target pressure at each of the percentage stages just here by 0.002. Again, this is totally just, changeable. So whatever you want to see, the pressure decay can't be less than. you're going to use this multiplier in here. Every one of them has separate multipliers, all the different components, but on this one, 0.002. So we'd multiply the target by that and then subtract that from the target. And so we've skipped that pressure decay because it didn't decay, obviously, because I didn't change this number. So it was satisfied with that. So we're pressure building now to 40%. So that would be 3,200 BSIA. So we've got the watchdog of 10 minutes, but so I'm just going to let this run a bit, and then I'll change up to 3,200. But I'll just explain what these buttons are. So there's some components that are high pressure components, like up in the 5,000-6,000. There's other ones at 250-300 psi. So not to be wasting time, you can skip those 20%, 40%, 60%, 80% decays, and just do 100% decay. Just bring it all the way to the full 100% set point, and then just do a decay test there. So we're doing a 40% pressure decay. So just to show how this works, let's skip the 60% one. Oh no, this is the 40% pressure target. So I'm going to skip the 40% and the 60% pressure decays. So we're just going to go straight up to a build of 80% of the target of 8,000, the full target of 8,000. Obviously, you can't skip the 100% decay because that's what tells you that the component passes the actual test. So we're going to skip the 40 to 60. First, we have to bring this up to 3,200. So automatically, the regulator is 3,200. So the PT4, PT3, obviously, they should be reading the same, but I'm just simulating this. So I'm going to bring PT4 up to 3,200. I've selected to skip 40 and 60%, so this should now go up to an 80% pressure build. So 3,200 PT4. So that's over 3,200 now. So now we're doing the 60. So we skipped the 40. So we have to do the 60% pressure build. Because but we're not doing the 60% pressure decay. We had selected 40 and 60. We skipped the 40. We have to do the pressure build, so it hasn't got to the 60 yet. So we're looking at 4,800. Okay, so now we've done that. So now we're going to the 80% pressure target because we had skipped the 60. We haven't skipped the 80% pressure decay. So we're just going to bring it up to 6,400, and then it's going to do the 80% pressure decay. So with the 80% target of 6,400, so we're going to, remembering that the parameter here was 0.002 for a pressure decay, we're going to what number again? Oh yeah, 4,800. Multiplied by 0.002 equals that, so 9.6. So 4,800 minus the 10, so 4,790. So around the 4,790 is going to be the oh no, it's 64. I should have done 6,400. 64. 6,400 multiplied by the 0.002 equals 12.8. So the 12.8, 13. 13 from, what is it? 6,400, so 6,387. So 6,387 or something like that, we'll see here. So let's pop that. So 6387, yeah. So let's pop that over the 6400. So that's over the 6400 now. 65, yeah. So that's over 6400. So now we didn't skip the 80% pressure decay. So now we're doing the pressure decay, the 1 minute pressure decay, because again, we've set up DTT, which is the decay test time in minutes. So 1 minute we've set it up for. So that's why that was that. So then we can see that, yeah, the decay test is 6387.2. So that was like the 13 or the 12.8 or whatever it was subtracted from the 6400 target, which is the 80%. So actually, let's just trigger an alarm here. Let's bring that down a little bit. Okay, so we moved the thing down so we can see pressure decay fail at 80%. So it's going to tell you that there's an alarm there. There's an alarm. There's lots of different alarms at the different pressures, the pressure bills. This was just an example of one. So it's saying pressure decay fail at 80%, under test the MGAG-0585. So it's going to tell you the component that's under test and at what part of the test it failed at. So 80% marker failed at pressure decay, and the component under test was the MGAG-0585. So this is all dynamic. So whatever you pick, it'll link itself together with the alarm and the component. The alarm and the component. So step fail, see alarm screen, press either stop button to exit. So it's fail at that. So then it tells you you can just press one of these to stop. So I'm just going to stop and vent here. And we've recorded to the logs that this has failed. So now I'm just going to go straight through and pass this. And just show you the end part of a test. So there's lots of different alarms. They're not shown up in the alarm setup, but these are all inbuilt now. And you'll just see all these. It'll just checking for the pressure bills, the pressure decays, etc. And so we'll probably go straight to 105 now because we're just keeping that pressure way above, so it'll have hit it. PT2 has reached the vessel high set point because we've simulated a value here in PT2. Press AC, ramping pressure, so performing leak checks. So I'm going to skip all these 20, 40, 60, 80. So we can do that because I've left that 6.1, so we're already into the 80% pressure target, 6400. Pressure build, because we're at 6143, 8,000. Let's bring it all the way up to 8,000. This obviously isn't the way that physically things will be working when you have pumps and everything, but this is just to show. So I'm just going to bring this all the way up to 80. Just going to reset that alarm because that was there. Show the step info here. A2. So they're doing a pressure decay at 100%. So this is the last part of it. Pressure decay at 100. Just while it's doing that, I'm just going to change a parameter for the vent. So it's going to be 19. We have to vent it under 19 psia for it to safely vent. And so I just want to set that to 60 seconds, just so I can get the value down to show that it's vented. So there's 14 seconds in this. So ramping the pressure. So this was the step we're in. So 4 seconds left. Test component has passed. Press active vent. So the test component has passed. So now the MGAG0585-kit there, just press AC. So then all of these open, and then we're looking to bring this PT4 down to less than 19 psia or whatever we put in there. So just bring that down low. So we brought that down to 18. So it's below the 19. Test component vented. Press a stop option to exit. So then again, you can see the time that it took to vent. So this will be like not even a second, or a couple of seconds or whatever. Obviously, depending on the pressure, but this can be used for data as well. So 18 point. So we just brought it down. So that's vented. So that's the test done. So that's the pressure decays, the pressure builds. That's simply that. And so there's lots of inbuilt alarms in it that you won't be setting up, but the ones that you will be setting up are the PT1 through PT4 in range. This just to make sure that none of those system sensors were ever disconnected. And you can set that up for a warning or a stop. Next one is alarm 6 supply door switch, which will be set to stop. Test component door switch warning, if these doors are opened. Safety relay de-energize set for shutdown, so this can't be changed. It'll always be shutting down. The EMO shutdown. The alarm 9 inlet pressure. Oh, this is just for low inlet pressure on the just before the pump. So you can set a value here that if PT1 is reading under it in auto mode, you get an alarm and say, okay, you've got to increase that pressure. So these are ones that you can set up for warning or stop. But then there's a lot more in there that you don't set up. It's just driven by auto mode. So I think that's it. I might just have a quick run over these, what they are. Vessel check pressure, time in minutes. That's just the watchdog timer to make sure that the pump is functioning with the vessel, pumping it up, that there's no leaks in the vessel or the pump is malfunctioning. The VSL HSP, this is just the target for what the vessel has to get to drive the pressure build test and leak decay and the decay test on the different components. TCP, test component pressure. This is the pressure that the test component has to be tested to. It's where you have to do final what it has to get to. AVOP, acceptable variance of pressure. This doesn't really come into it at the moment. This will be more if I get feedback. This is more integrity of the sensors and the regulator in there, that if we had to manipulate anything, as in, there's a little bit of drift. I'm not going to really talk about it at the moment, but maybe later. PDV, pressure decay variance. We talked about that one. That's just, you hit a pressure, it's held at that pressure, then where can we say that it's passed the test of it's not of the pressure decay, it doesn't drop below this number. So that's that. DDT, decay test time, that's simply how long do you want to run the decay test for. I just set it for a minute there, but it might be 5 minutes, 10 minutes, again, to be set up. Time and sub-step, this isn't important. You can probably put these to 0 or whichever. This was just, again, if there was any little bit of variation. They can probably all be set to 0 forever. And then SVSP, that's simply the system vent set point. So when is the system considered vented? And that might be 16 or 17 or again, depends how close you can get that PT So 14.7 or 12 or whatever it is for the atmosphere um, in Longmont. So whatever you can do, so whatever that PT you're reading to say that it's vented, um, just pick a number, 19. Um, Nothing's going to happen at 19 psi anyway. So then the next one, pressure build time monitor for 20 to 100%, target 20 minutes. This is just to monitor if there's anything wrong with the pressure build stage. Again, this probably won't be 10 minutes or anything close. It'll probably be a minute or whatever, just to make sure that everything is working correctly. And then the vent monitor, again, another just timer to make sure that the vent wasn't blocked. If it couldn't vent, or maybe a flow restrictor or something was closed up or something like that. So that's it. I don't think there's anything else. Alarm setup, unlog inputs. I think we talked about this. This is just where we set up all our devices. PT1. So everything in purple is the inputs. Everything here in blue is the outputs. So input decimal. Same before, analog to digital conversion. So analog 4 to 20 signal come in from the sensor. It's changed into a digital signal. Bit count. That bit representation here is in decimal form. So then we just have the scaling factors here. Don't need to worry about the engineering unit offset, I don't think, at the moment. Input minimum 0, input maximum 27648 decimal. So that'll always be the same throughout all the sensors we have in the system. It'll always be 0 to 27648. What will change is the scale maximum, depending on what sensor is in there, and that can be taken off the side of the sensor. Just what's the max scale of it. So maybe the PT1 is 250. We'll do this in setup once it's in and up and running, and the software downloaded. But 250 might be PT1's max scale, etc. So all the way around. Discrete inputs, discrete outputs. This is just showing the LEDs. This is a representation of what the PLC, what you'd see if you open the controller box. And then the same for the inputs. This would be a direct representation of what you would see if you open the controller with the LEDs illuminated. These inputs here, they're normally closed state, so 24 volts should be expected to be seen here on the discrete input channel. And yeah, I think that's it. So simply just picking a component and then just going through the pressure build stages, decay tests, etc. So I think that's it. All right, thank you.